Well, good morning or good afternoon, E-Techians. And today we're going to talk about energy. We're going to try to answer this question. What is energy? You are, after all, in the Energy Academy. I guess we ought to start somewhere. So what is energy? So take a minute to ask yourself, what is energy? Talk to the people in your group. Pause the video for a couple minutes. And let's do some brainstorming and write down some ideas. What is energy to you? So pause the video now. Okay, well, what is energy? Well, I'm going to, hopefully you've had a discussion here, but it all boils down, pardon the pun, it all boils down to this. Energy is the ability or capacity, or however you want to put it, to make change. Okay? Energy is the ability or the capacity for something to make change. Now look around you right now, or just think about your day, all the change that's going on, the change from getting up and getting ready to go in the morning, to breathing air, to consuming food, to thinking, to, everything that's happening around you is involving change. And if it involves change, it involves energy. Energy is the key idea to understanding how everything works. So, with it, and with a general definition like that, that might be kind of mind-blowing, but there are some things that, we're going to break it down into some specifics here, but there are three major ideas that we're going to start off with about energy in general. Energy can be stored up. You can store it somehow. There's lots of different ways of storing energy. Energy can be transferred. Okay? It flows. Okay? We can change where energy is. We can change how it's stored or manifested in nature, and that's a big idea, and you see that all going on all around you all the time. And here's a big thing. You've probably heard this before in your science classes, but energy cannot be created or destroyed. There is nothing you can do that can create energy. There is nothing that you can do that will destroy energy. All you can do is change how energy is stored, or where it is, or how it's manifesting itself in the world around you. But you can't make it from nothing. So energy, it's always there. No matter what you do, you are conserving energy. Energy is always conserved in every process there is. Okay, so let's get more specific about, we can see all these changes going on around, but how is energy stored? So here's the next question. How is energy stored? Okay, well, the first way I want to talk about is energy is stored in the motion of massive objects. If an object has mass, it's made out of stuff, and it's moving, it has what we call kinetic energy. So energy is stored in the motion of massive objects. Okay, So I have an example for you here. Here is a baseball that my daughter got at a Grizzly game several years ago. It's a foul ball. She actually got one. And now, imagine this baseball, and well, you don't have to imagine, it's right here, but it's not moving, so it really can't make a whole lot of change to the environment. For example, if I put my face under here, if I put my face right here in front of this baseball, right here, this baseball cannot make much of a change to my face, can it? It's just sitting there. But imagine, if you will, a baseball player, maybe some of you in here play baseball, throws this at my face at 100 miles an hour. Now, we've had a couple of our students have gone on to play professional baseball, and one of the things that they can do is they can transfer energy out of their bodies and into baseballs very, very, very effectively. So if this baseball is about to hit my face, and it's right here, but it's going 100 miles per hour in this direction, yeah, there's going to be some major change to my environment, to my face. Bone and flesh will be crushed. Okay, I mean, this thing can kill, right? So if an object, it has mass, that is, it's, you can feel its mass, but it's also moving, it has energy, and it has the capacity to make changes in its environment. And we call that kinetic energy. Okay? Kinetic energy. Now, there's another way that energy is stored in the environment. It's stored in the way molecules are arranged, atoms and molecules. Okay. Now, let me show you a little example of that. That's pretty cool. All right. Here's one of my favorite snacks: sun chips. Right. It's the Energy Academy. We got solar power. Might as well have some sun chips. Right. Now, this is food, and there's energy stored in this food, and it tells you how much energy is stored in the food. Okay. Look at this right here. 140 calories. Calories is a way of measuring how much energy is stored in food. So, if I eat this, here we go. Delicious. So crunchy and salty and good. I love sun chips. Now, right now, my teeth are crunching up into little tiny bits. And now I'm swallowing it. All right. Now it's going into my stomach. My stomach's going to mash it up and get it ready. Start breaking it down. And it's going to go into my small intestine. And in my small intestine, all those little molecules of fat and carbohydrates and proteins are going to be spread all over my body, and that's what lets me talk and lets me move. And my body can release that energy that's stored in those molecules to live. Right? If you don't eat food, you're going to die. Now, what does that mean? If you're dead, it means you're not metabolizing food. You can't think anymore. Your whole system is shutting down. It can't make change. I mean, because you're alive, you can make changes to your environment, and you need food to stay alive because you need to transfer energy. All right. So now, another example of that, of what energy being stored, is like this little Duracell battery right here. It's a little battery. There's energy stored in batteries, and the way the molecules are arranged in here. Now, this is not a rechargeable battery, but what happens here is that when you hook this up, a chemical change happens in here that happens to push electrons out, the negative end, and they flow around in a circuit, and you can get that energy out of it. Now, when all the chemicals are done changing, you you don't have any more electricity coming out of it. You don't have any more energy being transferred out of it, and it's dead. You have a dead battery. So we have a name for energy that's being stored in the way molecules are arranged, and it's called chemical potential energy. Okay, chemical potential energy, and that's a biggie. And unfortunately, right now over my gut, I've got too much chemical potential energy stored up, also known as fat. So if I eat too many of these sun chips, if I don't burn them off, I don't get enough exercise, all that energy I bring in, it gets stored up as chemical potential energy, and I gain weight. You need a little bit of fat, though. All right. Well, there's also energy stored in the atoms themselves, and we call that in the nuclei of the atoms. There's energy stored in the nuclei of atoms, and we call that nuclear energy. And we're going to study that in detail a little later on in the year. But I think, there's this molecule that you've heard of called uranium. I think it's uranium-235. It's this huge nucleus. It's not very stable, and it wants to push itself apart. And when it does push itself apart, it releases energy into the environment, in various ways. You can control it in a nuclear power plant, and we're going to get to go to Diablo Canyon later on this year. But or you can release it all at once or in a very short period of time to make an atomic weapon, and hope that never happens again. But anyway, that is another way of storing energy in the way in the atoms themselves, in the nuclei of the atoms. Now, a fourth way is we can store energy in the height of an object above the ground. Okay. Now, imagine somebody's standing right here. Here's a little stick figure person just standing right here, minding their own business, kind of waving at you. And somebody's holding a bowling ball, 4 feet over their head. Because this bowling ball has mass and it has a certain height, it could potentially change the environment of this guy's head, right? You release this bowling ball and bam. Okay, so there's energy stored in that. And by the way, and this is the energy that you find in a hydroelectric dam. All the water stored above the dam, there's energy stored because of the height and the mass of the water, and we can actually use that energy. So, we call this kind of energy gravitational potential energy. Okay. Now, another one. We can store energy in a compressed or stretched material. In a stretched or compressed material. It's just like a spring or a rubber band. Like, here's a rubber band. Okay. Now, if I stretch this rubber band, right? You ever done this to your little brother or sister? You take a rubber band and wham! Okay, yikes. Okay, so when I pull this rubber band back, I've got energy stored in there. I can make some change. Okay, you can fire it. Now, you can also compress. I mean, here's a little spring, right? Put the baseball on the spring and squish that spring down, and then whoop, whoa, Oh dear, dropped it. But anyway, you can compress the spring. It can save up that energy, and you can get it. Some pellet guns work that way. You know, you have spring-loaded pellet guns, and they compress. You compress them, and then they can fire. Oh, this is called. If I can fit this in here, elastic potential energy. Okay, so we actually have several potential energies here. We call them potential. We have the chemical potential. We have the gravitational potential energy, and now elastic potential energy. Energy that's stored up. And these are kind of based on the positions of positions of molecules, the positions of objects in a gravity field, the positions of objects that are stretched or compressed. Okay, and then another one that the last one that we're going to talk about right now in the way that energy is stored in the environment. So let's continue your notes on here. It's in the random motion of molecules. So we're all made out of molecules and atoms, particles, and actually they're all moving. Now, if I took a look at just a handful of let's just look at a few molecules. These could be air molecules, for example, in a gas, but they could be water molecules in your body or wherever. They're moving, but they're all moving in random different directions at different speeds. This one might be moving kind of slow. This one's moving kind of fast, but they're all moving. Now, atoms do have, and molecules have mass, right? So we have moving massive objects at a tiny, tiny, tiny scale. But so you might think, well, isn't this just kinetic energy? And it is related to kinetic energy. But this is like if I have this baseball, when this baseball is moving, all of these molecules on average are moving together. Okay, but these are not moving together. They're just all moving in different directions. This kind of energy is called thermal energy. Now, thermal energy can make changes to its environment. Now, don't try this at home, but I mean, take a pot of boiling water and stick your hand in it. Right? You're gonna see some change made. So that's energy, so objects, because they're the nature of their motion, they're moving in all random different directions. That has energy, and the study of this kind of energy is called thermodynamics, and the study of heat. Okay, so just to review, energy is stored in several ways through the motion of massive objects. I'm talking about big objects like baseballs and stuff. We have energy stored in the way molecules are arranged and hooked together. We have energy stored up in the nuclei of atoms, the nuclear energy. We have energy stored up in the height of objects, gravitational potential, in stretched or compressed materials. We call that elastic potential energy. And finally, in the random motion of molecules, energy can be stored up that way. So, now, how is energy transferred? In other words, how do we move and change energy? Okay, how is energy transferred? How does it flow? Okay, well, that's the question. Those are questions we're going to answer right now. Now, the first kind is very common. It's energy is being transferred through the application of a push or pull. Through the application of a push or pull. Now a push or a pull, it's another fancy way of saying that is a force. So if you apply a push or a pull on something, you can transfer energy from one object into another object. And the process of transferring energy through the application of a force is called work. Work. You are doing work when you push on something and you transfer energy into it because of that push. Now, for example, let's go back to our baseball example. When a pitcher throws a ball, he or she has energy stored in their arms, right? Look at these bad boys right here. Okay, there's in the muscle of your arm, okay, and body. There is energy stored, chemical potential energy, and then you can transfer some of that energy into kinetic energy of a moving ball by pushing on it. So when you throw a ball, while you're pushing on it, you're adding to the kinetic energy of the ball. You're doing work. Lots of examples of doing work. Anytime something's getting pushed or pulled and you're transferring energy from one system to another, that's called work. Okay. Work. Another way of transferring energy is through waves. Now there's lots of different kinds of waves. Light. Light is a wave. Light is a form of, let's just call it by its scientific name, electromagnetic radiation. Electromagnetic radiation, also known as light. Of course, there is some electromagnetic radiation that our human eyes can't see, right? But light is a form of electromagnetic radiation, and basically it's energy moving through space all on its own. We're going to talk about what light is a little bit later. But I mean, this is how energy gets to the Earth from the sun. The sun releases energy as electromagnetic radiation, and a little tiny bit of it illuminates the Earth, lands on the Earth, and we can absorb it with solar panels. And of course, wonderful plants have photosynthesis, and they can absorb some of that energy and make food through the process of photosynthesis. But it's electromagnetic radiation. It's energy in motion, energy being transferred, in this case from the sun to the Earth. Or, hey, here I have a little flashlight, and if I press this button, okay, I've got energy being, look, a change is being made. Isn't that awesome? All right. So, another kind of wave that you know about is sound. Sound is a way of transferring energy. The energy's in my in my body right now, and I'm pushing and pulling on air molecules, and that energy gets transferred through a wave into your ears or into the microphone of this document camera, and change is made. So it is a transfer of energy through sound. Okay. And another example of waves, of course, is water waves. Water waves have lots of energy in them. In fact, in some places they're trying to generate electricity by gathering the energy that's being transferred and moving through water waves. And we'll talk a little bit about that later in the year. Okay, another way energy is transferred is through electricity. Okay, now I shine this little light. Let's use it again. There's a battery in here that's storing chemical potential energy, but that through the flow of electrons in these little wires, we're able to transfer energy into these little light-emitting diodes, and of course those light-emitting diodes allow energy to flow into the environment through electromagnetic radiation. So lots of changes going on there. If you want to think about it, let's define it. It's the flow of electrons okay, that are all pushing on each other. Pushing on each other in a wire. Usually it's in a wire, right? So let's take a look at a little cross section of a wire here. Okay, so imagine this is a wire, and there's electrons that are free to move throughout the metal of that wire. Now, normally when there's no electricity flowing, these guys are just going all in random directions, running around the metal, holding the metal together, making the metal shiny and ductile and all that kind of stuff, malleable. Never mind. But what happens is that when I turn a switch on, like if there's a battery or a generator or some other way of generating this electricity, what you're doing is you're trying to stuff more electrons in here. Okay? You're trying to push them in here. Well, electrons, they don't like each other. They apply forces to each other, and they push each other away. So this guy pushes on this guy, but this guy pushes on this guy, and this guy pushes on this guy. And they all just kind of shove each other through that wire. And it's through that shoving and pushing of electrons through a wire that we're transferring energy from the battery to a light bulb or a little electric motor or whatever you got. So that's electricity. It's energy being transferred by electrons shoving and pushing on each other, which is kind of like work, isn't it? The definition of work is when you're pushing on stuff. But this is at a microscopic level with electrons. That's what electricity is. And finally, the last thing I'm going to talk about is we can transfer energy through the random collisions of molecules and atoms. Okay, now here's what I mean by that. Here's one example of it. Imagine you have a tank full of water. So here's my tank, the outside of the tank. And I'm going to put like a thin, like saran wrap or something right here. And this is kind of a cross section, so here's some water. Now the water on this side is really hot. And the water on this side is really cold. Okay, now if you insulate this from the environment and you wait a while, you know what's going to happen, right? I mean, what's going to happen here? The hot water is going to get cooler and the cold water is going to get warmer until, heat or energy is going to be transferred from the hot to the cold until it all reaches the same temperature, right? I mean, look, if you have hot coffee, you know that eventually that coffee is going to become room temperature. The hotness is going to leak out. Okay, well, we have a name for that. That's called conduction. At least, and because what's happening here is that these little randomly moving particles of water, these are moving fast and these are moving cold, but they bash into this barrier, and then these will slow down and these will speed up because they're all colliding with each other. Okay, so that's a form of heat transfer or heating, known as conduction. Another example of the random collision of molecules is, that if, let's say I have here's the ground, and here's a crate. And I'll demonstrate this in class here in a second. But if I kick this crate, what's this crate going to do? Well, it's going to slide across the floor, right? It'll have kinetic energy. But then eventually it will come to a stop. Okay, now that's because there's a force of friction on here, and that friction will do work, and it will transfer the kinetic energy out of the object and into the environment. And that environment, what do I mean by the environment? I mean the air, okay, and the ground, and the crate itself will all be a little tiny bit warmer. A little tiny bit warmer. Because that means that the molecules of the ground will be moving a little bit faster than they were before. So the nice organized kinetic energy of the moving crate gets converted into the random motion of the molecules of the air, the crate, and the ground. We have a name for this kind of transfer of energy. It's called friction, or frictional heating is a more official sounding way, but we can just call it friction for now. All right, and so we're done for today. We've talked about several things. Let's review them really quick. We talked about, hey, what is energy? Well, energy is the ability to make change in the environment. We can store energy, we can transfer energy and let it move around and flow in the environment, but we cannot create or destroy energy. All the energy we start with, we still got it at the end of any change. Now, there's various ways we can store energy. I can have a massive object that's moving. It's got kinetic energy. We can have molecules that are arranged a certain way, okay, and like gasoline or fat or whatever. We have energy, nuclear energy, the energy stored in the nucleus of atoms that can be released. You can hold a bowling ball over your head and say, oh, that bowling ball has gravitational potential energy. Or you can threaten to shoot your little sister with a stretched rubber band. That's called elastic potential energy. Or you can store energy in the random motion of molecules. That's called thermal energy. Boil some water, and you've got lots of energy stored in the random motion of those molecules. You can transfer energy. You can let energy flow by pushing on things. When you push on things, you're doing work. Or you can transfer energy through waves like light and sound, or water waves. There's other kinds of waves too. You can let electrons push each other through a wire, transferring energy from like batteries or generators to motors or light bulbs or cell phones, whatever. And then we also have the random collisions of molecules that allows energy to transfer, like through heating conduction or heating from friction. So that's all there is for today. Hope you took all these notes and hope it all made sense to you. And I hope we answered the question, what is energy? And prepare now to do some work. This is Mr. Lake. Goodbye.